Hello there. The last type of reaction we're going to look at is combustion of hydrocarbons. And so we're going to look at some of the different hydrocarbons and the ways in which they can burn with oxygen and some of the things to look at for hazards, etc., that go with it. So what is combustion? Well, combustion is the reaction of a fuel. In this case, it's wood in my image here, with an oxidizing agent. Usually it's oxygen from the air, right? And it definitely produces energy, right? You got heat and light coming off here. And that, in a nutshell, is combustion. So three things you need for combustion, as any firefighter will tell you, is that you need fuel, and you need oxygen or your oxidizing agent, and you need heat. So if you can reduce any of those things, you can put out a fire. And of course, if you want a fire, then you need all those in the right proportions in order to something to burn. So here are a few fuels that I found around my home here or in my everyday experience. Inside this little lighter, you've got butane. Inside here, you've got some propane for your barbecue. This is a gas range in our kitchen. This is methane primarily. And when you go to the gas station, it's mostly octane. You can tell this was a few months ago because gas prices are worse now. Okay, so in order for there to be combustion, you have to have those two things. And then there's the proportion thing to worry about. If you have unlimited oxygen, you will always get the same two products from combustion. You'll get carbon dioxide and water, and you just have to add up to see how many you need here. So we'll need two of these, and we'll need two of these. And so as long as there's at least 2 parts oxygen to every 1 part methane, then this reaction will go to completion and you'll get nice clean burning fuel. So it doesn't matter what the fuel is, you just write down the same 2 products every time, and then it's just a matter of balancing, right? So for the first one here, we have 2 carbons, there you go. We have 6 hydrogens, there you go. If we add these up, that's 4 oxygens there, 7 oxygens total. You can do it as a fraction if you want, 7 over 2. But for our purposes later on, you're going to need whole numbers. So if you get to this point where you have fractions that are in your balance, it's best to multiply everything by the denominator here, the 2. So this would be 2 C2H6s plus 7 O2s makes 4 CO2s plus 6 H2Os. Then you have nice whole numbers for your balance. For this one, let's see here, we got 3 carbons and we have 8 hydrogens. And if we add up that's 3 times 2 is 6 plus another 4 makes 10. So that would make this a 5. And we have whole numbers for this one, so we don't need to double to get a nice balance. All right, incomplete combustion. So if there is not enough oxygen for all of the fuel to burn, you can have some leftovers that don't get completely used up. And this can result in all sorts of things that suck. So if you have a look at these 3 test tubes, in the first one, we had the right proportion. You see it's nice and clean, only carbon dioxide was made, and there's no residue left over. In these other 2, you can see that there was some incomplete combustion. There was not enough oxygen to react, and you ended up with some visible product there. That visible product we usually call soot, and it's a mixture of like leftover hydrocarbon bits and some just plain carbon all by itself that's left over. The other thing that you can't see, but is often produced if there's incomplete combustion, is carbon monoxide. And we'll have a little look at that later. You can see that this one is going to be an incomplete combustion. Black stuff is already forming at the end there. So let's look at some possibilities for incomplete combustion. We have the same setup, the same reactants as before, only this time we are limited in the amount of oxygen that we have. So with 4 oxygens here, I could make, let's see here, how many waters can I make? I always start with the waters. So we could make 3 waters because I have 4 oxygen, so I can use 3 of them for the water. Now I only have 1 oxygen left. So I can make a carbon monoxide with one of these carbons, and then the other carbon would just be left over, and we could call that soot. All right, let's look at this other one down here. This time we have a hydrocarbon that has 3 carbons, and we have 6 oxygens in order to burn it with. That probably won't be enough since this is incomplete combustion we're looking at here. Let's start with the waters again. We can make the 4 waters out of that, and so that means we're down to 2 oxygens left. We could do carbon dioxide if you want, and then that leave 2 carbons left over as our soot. The other option is we could make 2 carbon monoxides and only have 1 carbon left as soot. So both of those would be correct. There are probably a whole bunch of side reactions going on here and different combinations that form. And so when you're balancing or completing an incomplete combustion, as long as all of the elements balance on either side, then you're okay. So both of these are fine. Now, there's some other problems with incomplete combustion that you should know about because it is something that you'll be around your whole life. If there's incomplete combustion, there's going to be some soot around, and soot makes these fine particles that people breathe in and can end up down in your lungs, and over time can cause problems. Things like heart attacks and cancers become more prevalent when there is tiny soot particles down in your lungs. So that's one reason to avoid incomplete combustion, or smoking, for that matter, does the same sort of thing. Another thing is that if you're using combustion to provide energy, whether it's for motor or for heating your home, then you're going to lose some of the efficiency. Some of that uncombusted carbon is not going to be providing the energy that you wanted to use it for. So it's a loss of energy and loss of the purpose of the technology that you might be using it for. You won't get as much heat out of your furnace. You won't get as much mileage out of your fuel in a car. And the last thing here is if you have incomplete combustion, carbon monoxide is one of the products, and this can be quite deadly. And that's why you want to be careful to avoid any situation where you might be around incomplete combustion. So carbon monoxide, a little closer look here. Carbon monoxide is a very similar structure to oxygen gas, right? And so it will stick to the proteins that carry oxygen in your blood the same way that oxygen does, only it doesn't let go as easily. When it gets to the other end, to your capillaries where it's supposed to be nourishing your cells, of course it's not oxygen, and so your cells will start to be deprived of oxygen, and all those spots where oxygen should be in your blood are going to be occupied by the carbon monoxide. So it's very bad to be breathing this for very long at all. So most of your homes should have carbon monoxide detectors, if not built in. At least I have one of these plug-in ones that's on the same level as my furnace, so that it can detect if there was ever malfunction that led to some carbon monoxide. And some other characteristics to know about carbon monoxide, that it can lead to a few of these types of symptoms. Of course, you can't see it or smell it or taste it, and but you might be able to detect if someone has a headache and nausea and dizziness if they're in an area where there is potential carbon monoxide that could cause this poisoning. Of course, the extreme end of things is collapse, loss of consciousness, and even death. So make sure that you're not exposed for very long, or if you see something like this, that you open some windows and get some help.